Hi everybody, this is Dr. Hamid with your College Mathematics 120 class. Today we'll talk about section 5.6, which is about exponents and scientific notation. In this section, we will talk about how to represent big numbers using scientific notation, and we'll talk about exponents, properties of exponents. We will learn how to write big numbers into scientific notation, how to go from decimal notation to scientific notation, and from scientific notation to decimal notation. We will look at few examples on how to perform computation using scientific notation, and then we'll look at a couple of examples, where scientific notations are helpful while doing arithmetics. Um, just to give you an idea of scientific notation, okay, this is a very neat idea. It's a quick and easy way to write really big or really small numbers, okay, into a into a short way. Okay, so what is the basic idea? Basic idea is to use the powers of 10. So with that we can create short versions of long numbers. So to write numbers in scientific notation, okay, we it they are run they, there are two components, there are two pieces when we write in a scientific notation. Okay, the first piece is a number, an integer. Okay, it can be real number as well, I'm sorry. Okay, it's a number, any real number between 1 and 10. Okay, it can be equal to 1 but it cannot be equal to 10. It has to be less than 10 and bigger than 1. Okay, so this is one piece, and the second piece is, we will multiply this first number with the power of 10. For example, if you want to write this big number in a scientific notation, I'm not going to tell you right now how, but it will be written compactly, shortly, like this one. So okay, so this whole number 137 million, we can write it as 1.37 multiplied 10 to the power 8. Okay, so if you look at it, going back, in proper scientific notation, the number must be written with two parts. First part is a number between 1 and 10. In this case, it is 1.37, and then it has to be multiplied with the powers of 10, which is this one, 10 to the power 8. Okay, we will learn how to do this, how to write this in coming slides. Now, since there are exponents involved here, okay, so let's start this by learning some properties of exponents. Okay, so if two exponents are multiplied, okay, it's called a product rule for exponents. If you have the same base, for example, b to the power m times b to the power n, then we can write it in the same base and the powers must add. Okay, for example, if you multiply 9 to the power 6 times 9 to the power 12, we can write it as 9 to the power 6 plus 12, okay, which will be 9 to the power 18. Now in words, when multiplying exponential expressions with same base, which is b in this case, which is 9 in this case, okay, add exponents and use this sum as an exponent of the common base. Similarly, we have a power rule, which means that if you have a power of a power, so we have b to the power m and whole to the power n, then what happens? Then these powers multiply. So we have b to the power mn. Okay, so as an example, if you look at 3 to the power 4 to the power 5, okay, so power of a power, that means powers multiply. So we will have 3 to the power 20. Okay, similarly this one here. The last one is the quotient rule for exponents. So if you have a division of two things with the exponents, okay, b to the power m divided by b to the power n, then we can write it in a same base, but the powers will subtract. So we'll subtract m minus n as a power. Okay, for example, if you want to simplify 5 to the power 12 over 5 to the power 4, that will simply be 5 to the power 12 minus 4, which is 5 to the power 8 here. Okay, I hope you got the idea how to deal with exponents. Okay, now let's move on to the very famous rule we learned in high school. Anything to the power 0 is always 1. Just keep that in mind. Okay, it's called zero exponent rule here. Zero exponent rule. Okay, so mathematically speaking, if b is any real number other than 0, okay, and then b to the power 0 is 1. Okay, similarly, as an example, is 7 to the power 0 is 1, minus 5 to the power 0 is 1. Okay, pi to the power 0 is 1. Anything to the power 0 is 1. Only you have to pay attention when you're, this one is minus 5 to the power 0, which is 1. Here we have minus and then 5 to the power 0. So basically this means minus is outside and 5 to the power 0 is 1, and this minus will give you minus 1 there. Okay, I will put a problem like this on the tests. Okay, so make sure you pay attention to that. The next one is the negative exponent rule. Okay, if b is a real number other than 0 again, okay, and m is a natural number, then b to the power m is same as, if we write it as a ratio, as a fraction, if we bring this to the denominator, it will become positive. Okay, so b to the power minus m is same as 1 over b to the power m. Okay, so we can go from here to here or here to there. This is called a negative exponent rule. How to deal with the negative exponent? If it's negative in the numerator and we bring it to the denominator, it will become positive. Okay, and the other way around as well. So let's look at an example using negative exponents. We have to simplify the following negative exponents. If you have 8 to the power minus 2, what does it mean using this one? It means 1 over 8 to the power 2, and 8 to the power 2 is basically 8 times 8, so it's 8 to the power minus 2 is 1 over 64. Similarly, 5 to the power minus 3 is 1 over 5 to the power 3, which is 1 over 125. Okay, let's look at powers of 10, because that will be an important piece of our scientific notation. A positive exponent, if you have positive exponent, that tells us how many zeros follow 1. For example, if we have 10 to the power 9 here, okay, this basically means, okay, is 1 followed by 9 zeros. That's what it means. Okay, if you want to write it explicitly, so it will be 1 and then 3, 3, 3, 9 zeros. Okay, 1 followed by 9 zeros. Now, if you have a negative exponent of 10, okay, that tells us how many places there are to the right of the decimal point. Right of the decimal point. Okay. For example, if you have 10 to the power minus 9, it has 9 places to the right of the decimal point. Okay, so there, if you want to write it in explicitly, you will have 9 zeros on this side and then 1. Okay, now let's go to scientific notation. Okay, a positive number is written in scientific notation when it is expressed in this form. So this will be our scientific notation. We will have a times 10 to the power n, where a is any number greater than or equal to 1, okay, and less than 10. It has to be strictly less than 10. And what is n? N is an integer, which is a power here. That has to be any integer. Okay, let's look at it, how you go from scientific notation to the long way, the decimal notation. Okay, suppose 8 times 10 to the power n is given to you. Okay, now if n is positive, one situation is we can have n positive or negative. If n is positive, let's say 6. If n is positive, then we move decimal point in a to right n places. Okay, if n is positive, we will move the decimal to right n places. Okay, now if n is negative, then we'll move whatever we'll move, it will be positive absolute value of n. Okay, so whatever, even if n is negative, we will make it positive. So if n is negative, move the decimal point in a to left n places, absolute value of n places. Okay, let's look at an example. Suppose you want to write in decimal notation. We have 1.375 times 10 to the power 10 in decimal notation. Okay, so what is n? N is positive here. N is positive. Okay, now what our rule says that move the decimal point in a, okay, which is a is this one, 1.375, right n places. So we have to move this decimal 10 places to right. So right is this side. Okay, so let's do that. So this was this one here. So we have to move 10 places. So 3 is already there. So we have 1, 2, and 3. That means we need 7 more zeros. So 7 zeros are here. 3 zeros are when. This is your decimal notation. Okay. Now let's look at second example. So as a second example, we have a negative exponent. Okay. So this time we have to move the decimal point in 1.1 to the left. Okay, move the decimal point to left. So if there are not enough, we will put zeros there. Okay, and we have to move it absolute value of n place. So we have to move 4 to the left. So this is already here. We have to move 4 to the left. So 1 is this, and then we have to have 3 zeros. So that's how you got this one here. Okay, I hope you got the idea here. Now let's move from decimal to scientific. Okay, a long number is given to you and we want to write it as a times n to the power n. We have to find a, we have to find n. Okay, a is the numeric factor, so move the decimal point in the given number to obtain a number greater than or equal to 1 and less than 10. Okay, and then find n, which is the exponent, has to be exponent, which will go up there. Okay, so the absolute value of n is the number of places the decimal point was moved to get a number between 1 and 10. Okay, the exponent is positive if the given number is greater than or equal to 10, and it is negative if the given number is between 0 and 1. You will look at examples and you will understand that. So we want to write each number in scientific notation. First look at this one here. Okay, so we want a, which will be between 1 and 10, so that will be 4.6 here. Okay, and then we want 10 to the power, how many decimals? So decimal is right there here. Okay, right now decimal is all the zeros here. We are moving the decimal to this side, so we move 1, we move 2, we move 3, we move 4, 5, 6. Okay, so this one here, so it has to be 4.6 times 10 to the power 6 right there. Okay, now look at this one with a negative exponent. Now this time decimal is here. Okay, so now what do we want to do? We want to move the decimal to right. Okay, we want to bring it this, we want to make this number between 1 and 10, so we want to make it 2.3. so how many we move? 1, 2, 3, 4 and 5. Okay, so it will be 2.3 times 10 to the power minus 5 there. We can multiply numbers in scientific notation. It's easy. We will use the laws of exponents. Okay, if you want to multiply a times 10 to the power n and b times 10 to the power m, what will happen? We'll multiply a with b and then multiply 10 to the power n with 10 to the power m. Okay, a times b will be a simple multiplication. 10 to the power n times 10 to the power m will be 10 to the power n plus m. Powers add. Remember the exponent rules? Okay, now add the exponent on 10 and then multiply the other parts of the number separately. That's what it says. Okay, look at this example here. Suppose you want to multiply 3.4 times 10 to the power 9 and 2 times 10 to the power 5. Okay, so what will happen? You will multiply 3.4 with 2. Okay, and then you multiply 10 to the power 9 and 10 to the power minus 5. If you multiply these two, that will give us 6.8. When you multiply exponents, powers add, so that will give us 10 to the power 4. So this is your final answer. Okay, and if you want to write move the decimal to the other sides, if you want to write it in a long way, just move the decimal to right 4 places. So 1 is already there, 3 more add. Okay, so that's your answer. We can also divide using scientific notation. Okay, big numbers we can divide them. So what we will do, we'll again use the exponent rule for the quotients. Okay, and if you have dividing a times 10 to the power n and b times 10 to the power m, so what you will do, you will find the ratio of a over b. Okay, and then apply the laws of exponents on 10 to the power n and 10 to the power divided by 10 to the power m. So that will just be a subtraction of the powers. Okay, look at example here. So suppose you want to simplify 8 times 8.4 10 to the power minus 7. Okay, pay attention, it's a minus 7, and 4 times 10 to the power minus 4. Okay, so what will happen? We will divide 8.4 divided by 4, which gives us 2.1, and then we divide 10 to the power 7 minus 7 divided by 10 to the power minus 4. Okay, so here we apply the exponent rules. It tells us that when we bring it to the same base, the powers will subtract. Since both are negative already, so minus 7 minus minus 4 will become plus. So we'll have minus 7 plus 4. That will give us minus 3. And we can have this as our final answer. Okay, that's how we can deal with big numbers using scientific notation. um, yeah. Let me finish this lecture with a one real life example where we deal with big numbers. Okay, let's talk about our national debt. Okay, we owe about 15.2 trillion dollars. That's our national debt here. If you write it in a scientific notation, that means 15.2 times 10 to the power 12 here. Okay, now okay, I copied this example from the book. It should be 1.52 and 10 to the power 13 basically. Okay, I don't know, I'm not sure if I corrected it. If not, I'll correct it right now. Okay, and our population is 312 million approximately. Okay, if you write it in scientific notation, it will be 3.12 times 10 to the power 8. Now suppose we want to find out how much each one of us owe. Okay, so if you want to pay off our debt, how much every citizen has to pay. Okay, so basically it boils down to the division. Okay, the amount each citizen would have to pay is the total debt, this one, divided by the number of citizens, which is our population, 3.12 10 to the power 8 here. Okay, so let's perform the division here. Okay, it will be 15.2 times 10 to the power 12 and 3.12 times 10 to the power 8. So we will divide these two numbers. So 15.12 divided by 3.12, that gives us 4.87. Okay, and then we'll deal with the exponents here. We have 10 to the power 12 divided by 10 to the power 8 here. When you have a division of exponents, powers subtract. So it will be 10 to the power 12 minus 8 here. So it will be 10 to the power 4. Okay, and if you write it in a a common language, long frame, it turns out that our number turns out to be $48,700. Okay, so if we want to pay off our whole national debt, every one of us have to pay approximately $48,700. Okay, that much we owe. So this was an example of how to divide numbers in scientific notations. Thank you very much. This was an easy lecture. I hope you understood everything. Okay, try the problems assigned in my math lab. Very similar problem we discussed here. I have assigned you there. Okay, if you need any help, contact me. Thank you very much. Bye bye.